two parts. And the first one is that we're going to show you that when you have a usage-based pricing plan, okay, and then adding an additional fixed fee pricing plan is always optimal. Okay, here, this term is not saying that using a fixed fee pricing plan itself is optimal. Okay, it's saying adding it into an existing usage-based pricing plan can increase your profit if you design this plan carefully. Okay, we're going to show that in this part of analysis. First is that we need to somehow get some idea about our usage-based pricing plan. So if I'm going to use this notation, okay, QT pair, to say it's a menu. If our menu is incentive compatible, okay, we can show that the following things applies, and that's something natural. First, monotonicity, okay, and then when Q is larger, transfer payment needs to also be larger, natural. Also, this difference is the consumer's surplus for a type data agent, okay. When you have a higher type, you are going to earn more. Some kind of increasing information rent property. Okay, this is also natural because as a high type consumer, you have the informational advantage to pretend to be a low type. That's why if a contract schedule is incentive compatible, you are going to earn more than those guys that cannot pretend to be you. Okay, so that's the idea of lemma 1. Something you can show, but we're not going to show it here. But you may check the appendix. Okay, so now we have an incentive compatible schedule. It may not be optimal, but at least it is reasonable, right? Because it satisfies the condition we need. Okay, so now let's ask what will happen if we add the optional fixed fee pricing plan. When we add this plan, that means the consumers have one more choice. So we want to ask, when will one guy select this particular fixed fee pricing plan? So naturally, if I'm going to buy it, that must be because it gives me a higher utility. In that case, I'm going to earn this utility minus the payment. This must be higher than my original payment under the original usage-based pricing plan. Okay, I don't need to worry about whether this is going to be positive or negative or whatever, because this part, according to the IR constraint, must be non-negative. So all I need to worry about is whether this new option, okay, is better than my current option. So if I can do some arrangements, I'm going to make T to the right-hand side, these two terms to the left-hand side. I know that these three terms together gives me this new function psi. Okay, this psi function is the type theta agent's willingness to pay for the all-you-can-eat option. Okay, that means as a type theta consumer, I will evaluate these three quantities to see whether I want to pay for or whether I want to switch to the all-you-can-eat plan. Okay, I just need to check whether my willingness to pay is higher than or lower than the transfer. Okay, so that's the rule for me to switch or not. And now let's write down a condition or a property for this psi function or a willingness to pay function. Okay, this property is also not very surprising to us. This says that the willingness to pay for the all-you-can-eat plan will be strictly increasing in theta. Okay. In this video and in most of the time when I am doing presentation, when I write an arrow like this, okay, from the left bottom to the right top, that means weekly, at least weekly increasing or non-decreasing. Okay, when I write this means strictly increasing. Okay, yeah, not a big deal. So we can show that the willingness to pay for the all-you-can-eat plan is going to be strictly increasing in theta. So again, that's natural. When I have a higher type, when I prefer this Wall Street Journal more, I will be more willing to pay for the unlimited access. Okay, so that's the idea for Lemma 2. Lemma 2 is not surprising, but it allows us to derive the following proposition that is more interesting and contains more findings to discuss. Okay, this will be our proposition 1. In proposition 1, we provide you a property for what's going to happen when I introduce a fixed fee option into an existing incentive compatible menu. There are naturally two possibilities. If t is extremely small, for example 0, it's possible for you to see everyone switching to the all-you-can-eat plan. Or if t is so high, everyone will stay to the original plan. Or if t is moderately high, then some will move and some will not. Here I'm going to write down who is going to move and who will not. The result is like this. It's again not so surprising. There will be a type theta f. Okay, this type is the minimum theta that makes one guy be willing to switch to the all-you-can-eat plan. Okay, because this willingness to pay is equal to the price. There exists such a type such that for all the guys above it will switch, and all those types below it will remain in the original plan. Okay, so that just means if this is consumers from theta low to theta high, there will be a cutoff. We call it theta f, such that all the people above it will switch to fixed fee, and all those people below it will still be using usage-based pricing plans. Okay. Again, that's not very surprising, right? Because those guys has higher types, will have higher willingness to pay. If this guy is willing to switch, all other guys above it is willing to pay more for this plan. So they will also be willing to switch. For all other guys below it, they will not, right? So this is something fits our intuition, but rigorously like this. Okay? Yeah. So now with this in mind, probably we need to ask a question. The question is, we know introducing tea is going to typically attract some consumers to do this all-you-can-eat plan. That's going to affect some things. So first is that for this part of consumers, I do not need to pay the transaction cost. So that's certainly something good to me. But also at the same time, there must be some consumers within this region that will pay less to me, right? Okay, because originally when they are paying according to their usage, then when I am designing this transfer T, okay, this price for all you can eat, the price must be not so high, so that the consumer here will switch to all you can eat, okay? And in that case, though for a sufficiently high type, originally he wants to pay more, but now you are offering a too generous plan to him, and he is going to pay less than the original situation. Okay? Imagine that if originally you say one newspaper article charges you $5, okay? And there are still some people who is willing to pay a lot for reading a lot of newspaper articles. But now you say 500 for unlimited access. Those guys who originally are willing to pay more than 500 is going to benefit from that. So you are facing a trade-off, saving some money, okay, saving those transaction costs, and losing some money because you are too generous to those guys. Okay, so you're asking when is introducing a T into the existing IC menu is optimal. Okay, let's assume we fix the current incentive compatible menu, and we ask only whether introducing a new option is good to me. Okay, I'm asking this question, and if you think about this situation, certainly if there is a trade-off, naturally we think it's possible to be good and it's possible to be bad. Okay, here we're saying that it's not like our conjecture. Introducing T is always good, and it can always strictly improve our profit. Okay. So the results are stated in proposition 2, but before that we need one more lemma. Okay, lemma 3 is saying that suppose I am using an optimal incentive compatible usage-based pricing plan, and that's optimal when there is no fixed fee option. Okay, at this moment I do not know how to find it, but let's assume it exists and it is optimal. Then the property is the following: for all the consumers I can get, okay, this is the amount I earn from this type of consumer. Okay, I can earn a non-negative amount, and the amount I can earn is going to be non-decreasing according to their types. So that means for a high type, for a consumer that is more willing to buy my product, I am able to earn more. Sorry, to earn more from him. Okay, so that's what is mentioned in this lemma. Okay, again, we're not going to prove it, but this somehow is reasonable. For those guys who want my product more, I can earn more from them. With that, we're going to show you proposition 2. Suppose there is a positive transaction cost whenever consumers consume something. Okay, suppose this is the case. Whenever there is a transaction cost, offering a well-designed fixed fee option, okay, is always strictly profit improving. So, I mean, we have found the optimal usage-based pricing plan. Okay, we have that. And then we ask, if we are allowed to offer the all-you-can-eat plan, will we earn more? We know we're not going to lose anything because we can choose t to be infinity, so that offering it just means do not offer it. Okay, that's possible. So we cannot lose anything when we have more options. But does that option really benefit us? The result is true. Okay, as long as we design it in a good way, we can strictly improve our profit. So that's why this is the case. Okay, so the key is that this transaction cost is positive. If there's no such transaction cost, then it's possible that offering a fixed fee option is not beneficial. Okay, so that's why this is the case. Suppose, and I'm going to assume that this is positive. What does that mean? I'm going to assume that at least for the highest type, I want to sell something to eat in my original plan. Okay? If that's not true, then it's immediate to show that offering this fixed fee plan is optimal. Because if this is equal, if the quantity here equals 0, that means I do not sell to everyone. Then I can use fixed fee option to at least earn some money. Okay, so I'm going to assume this is positive. In that case, certainly I know the associated cost is positive, right? And I can do the following. I will be able to find a capital T within the following region. Okay. I know tau star of T. Tau star of this should be for the highest type. I know for the highest type, he is something, so I charged a positive amount from him. And I know C is positive, so there is a gap between this side and this side, and that's why I can find a T in between. Okay, so now there is a T satisfying these two inequalities. In that case, I can see that this T or this all-you-can-eat plan is attractive to the highest type, because the highest type now can pay less but eat more, right? So the highest type is going to transfer to the all-you-can-eat plan. He needs to pay less, but he can eat more. Okay, so that's one condition. And also, for the highest type, this plan is profit improving. Why? T is greater than this. What's this? This is the amount I may earn without the all-you-can-eat plan. Originally, the highest type is going to eat this amount and pay me this. This is the original amount I may earn from him. This is the amount I may earn after he switch, right? Because I don't need to pay this transaction cost anymore. So this, for this particular introduction, is profit improving for the highest type. Now I need to ask, what's going to happen for the other types? Okay, according to our argument, this plan is going to make the highest type switch to the all-you-can-eat plan, right? And if that's the case, there must be a group of consumers. As long as their type is high enough, they are going to switch. Okay, for those consumers among the highest types, they will all buy this all-you-can-eat plan, as long as this is beneficial to them. Okay? Now I know some of them will switch, some of them will not. For all those guys who will not switch, I know I earn the same thing to them. So now I need to ask, for this group of consumers who all switch, do I earn a positive amount? So for each consumer within this region, I ask what's the quantity, what's the amount I may earn in my original plans. Okay, in my original plans. I know in my original plan, this is going to be bounded above. Right? According to the lemma 3, when one guy has a higher type, I will be able to earn more from him in my optimal incentive compatible usage-based pricing plan. So no matter what's your type, the amount I may earn is bounded above by this. And also, this is less than T, right? Okay, I can earn more by making them to the all-you-can-eat plan. And this is true for all those guys that will switch. So I know when I do this,